Okay, so we're up on the roof. All right, this is a practical situation. We're on the warehouse. Where are the nearest mobile towers? We're going to use the online website to locate them. We're going to use our eyes to see if we can see them, and we're going to use the spectrum analyzer. Okay, we use the Yagi antenna. So basically, you start off just choose a band. I like to choose 2100 megahertz. Okay, because it's a very it's used with all the operators. All calls generally go out over 2100 megahertz. So I just put in the 2100 megahertz spectrum, and I try to balance it. I look at it like that, and I say, okay, let's balance up these. Okay, this is a good direction. I know the mobile towers are there. Perfect. Fix the antenna into position. Put it on a temporary pole. Put it on a pole. So install the Yagi in the best direction. Next thing what I want to do is I want to connect the eye repeater up. So let's do that right now. So this is a very good tool because this will tell you the information we want to know is how long a piece of cable can I put between the outdoor antenna and the repeater. Up until now, what installers do is they just look at the manual, and the manual says 30 meters, a set amount, 30 meters. And the installers know, okay, I know not to go beyond 30 meters, right? But with this tool, you can now know precisely how much cable I'm allowed to use. And sometimes it's greater than 30 meters, and sometimes that's useful because we need to put a big piece of cable in. All right, so this is how we find it. I'll just plug it in here. I'll be on the roof now, I'll be on the roof of the building, and I just look at this dB page. Well, what this is basically telling me here is total loss dB. Okay, now the only figure I have, they're all zeros. Just reset that. So it's not great. We have to go outside to do this. That window open. It'd be interesting to see when we get signal in. It worked. Wow, look at the difference. Look at the difference. Wow, so that window is completely isolated. That's very interesting to see. So now we can see straight away, look at these figures. It's unbelievable. So we can see, so these are total loss figures, okay? So what this repeater is saying, it's saying we have a lot of power. We have so much power, I'm adding attenuation to the system. I'm throwing away the power. The power is coming in and the repeater's throwing it away. Right? But instead of throwing away that power, instead you can put a big long cable in. Right? So let's just use, what's the best one? Let's say we're installing a repeater system for 2100. So let's say we got 26 dBs at 2100. Okay, that's all the information you need to know. We just always use the highest frequency, okay? So you can say, I'm allowed to have 26 dBs at 2100 megahertz. We know that the cable has a loss of 0.2 dB meters per meter at 2100. So how long a piece of cable can we use? So 26 dBs divided by 0.2 was 130 meters. So you could put a 130 meter length of cable between the outdoor antenna and the repeater, theoretically. It's a lot more than 30 meters.
Yeah.
No, right?
It's 100 meters.
Because that's what it's telling us. That's what the repeater's doing. The repeater's throwing away an enormous amount of power. So there's literally an enormous amount of power coming in that window right now. We must be very near a base station. I wouldn't be surprised if over the other side of that building there's probably a base station. I wouldn't be surprised. So that's good. That's great information to have this. So what we do here is we take that information down. We would just write those numbers down on a notepad, and with those numbers we can put them into the design tool. So we have a record of them in the design tool, and now the design tool knows what the signal power is like in the roof, and it can work out calculations about cable lengths and all that. And we will do that. We'll do an example of that. In fact, let's do it right now. We may as well do it right now.